Okay, so did you get this answer when you practice it? X to the 12th plus 6x to the 10th plus 15x to the 8th plus 20x to the 6th plus 15x to the 4th plus 6x squared plus 1. And if you didn't, it's possible I have a mistake, but otherwise I think it's correct. It should be x to the 12th, then 10th, then 8th, then 6th, then 4th, then squared, then 0. So remember, first I did my coefficients, Pascal's triangle. This is my row, 1, 6, 15, 20, 15, 6, 1. Then I took this x squared. It's x squared to the 6th power, x squared to the 5th power, x squared to the 4th power, x squared to the 3rd power, x squared to the 2nd power, x squared to the 1st power, which is why I have these even exponents. Instead of just being 6, 5, 4, 3, 2, 1, it's 12, 10, 8, 6, 4, 2, 0. And this 1 was super easy, right? 1 to the 1 power, 1 squared, 1 cubed, 1 to the 4th, 1 to the 5th, 1 to the 6th. Well, that had no impact, so that was really nice, actually. Made it a little bit easier. So again, lay out your coefficients, lay out your first term's exponents decreasing by 1, your second term's exponents increasing by 1, and because there was a plus sign in the middle, all my signs just stayed positive. If it would have been a minus sign in the middle, then my signs would have alternated, just first term positive, then plus minus, right? This first term positive, negative throughout. Okay, now what happens when we want to find like a 5th term of something to the 9th power? Well, that's a nightmare to keep doing Pascal's triangle all the way down to the 10th row, which is actually the 9th, row 9 instead of row 0, 1, 2, 3, etc. So row 9, that would be so time consuming. So instead we need a little shortcut. So that's where the combination formula comes into play. So combination formula will help us get the coefficient of the term that we're looking for. So the kth term of binomial expansion raised to the nth power. So n is the number right here, the power that it's being raised to. And k, well, because the first term in the expansion can be found by setting k equal to 0, then notice the second term is going to be k equals 1. The third term is k equals 2, so it's always 1 less than the term we're looking for. So we're trying to find the 5th term, then I want my k to be equal to 4. So my coefficient for this term is going to be 9, choose 4. Right, and then I'm going to multiply that by 2x, because this is my first term, that's my letter A right here, to the n minus k power, times my second term, which is negative 1, to just the k power. So I do 9 factorial divided by 9 minus 4 factorial, and then 4 factorial again, because the combination formula is to do the subtraction and then write down the r factorial again. And then I have to multiply 2 to the 5th power times x to the 5th power. And then I have to multiply negative 1 to the 4th power, but a negative to the 4th power just turns it into positive 1. So this almost doesn't have any place value. It really determined if this should have been a positive or a negative answer. So use your calculator, otherwise you didn't need to write this out right here. You could have just used your calculator and done 9 choose 4, so I'm doing that now on my calculator, and that's 126. So this right here becomes 126, 2 to the 5th is 32, x to the 5th, and then the positive 1 has no significance. We're multiplying by positive 1, so this simplifies to 4,032 x to the 5th power. So the 5th term of this sequence is 4,032 x to the 5th power. Now if you forget this negative with the 1, then you should just say to yourself, remember when we were expanding and I said the terms alternate? Your first term was positive, your second term would have been negative, and your third term would have been positive, and your fourth term would have been negative. So your even terms are negative and your odd terms are positive. Therefore, this was a 5th term, it's an odd term, so my answer should have been positive, so that kind of works out to be exactly what we were talking about. So there's a bunch of little connections that I'm trying to make, but I know that it's hard. So you might want to listen to this video more than one time because there's certain little tricks that help you. And the more you practice, the easier it is. But please ask me questions in class. Okay, so I'm finding the 12th term in x plus y to the 12th power. So again, go through this. N is equal to 12, right? That's the exponent. K is equal to 1 less than the term that we're trying to find. So K is equal to 11. So it's 12, choose 11, times x to the 12 minus 11 power, y to the just k power, which is 11, and there we have it. So 12, choose 11, that's just 12, x to the 12 minus 11 is 1, and y to the 11th, so this is my answer. It's a plus sign in between, which means all terms are positive, so it's just 12x y to the 11th. Well, remember at the beginning when I said an expansion, another connection? Your expansion has one more term than its exponents. There are 13 terms, and if you look at Pascal's triangle on the first page, you see that every first coefficient, we go up here to Pascal's triangle, this first and last coefficient are 1, and the ones right in between are the expansion. If it was to the 4th power, then it's going to be a 4 here. If it's to the 5th power, we have a 5 here and a 5 here with 1 left. So if it's to the 12th power, the term right before the end, there's 13 terms altogether, so the term right before it is going to have that same exponent as here, and then it's x to the 1st power y to the 11th, because the final term would just be y to the 12th power. Right? Okay, moving on. Number 7, it says find the first 3 terms of x minus y to the 24th power. Okay, again, going back to Pascal's triangle, trying to get you to recognize some of these patterns, right? So I said the first term is always an exponent, a coefficient of 1. The second term is always the coefficient of whatever the exponent is. So this is kind of easy. The first term has to be 1x to this exponent, 24th power. And then remember, if it's a negative sign, it has to alternate signs. And the second coefficient is whatever we raised it to the power of. So it must be 24x to the 23rd power. And then now we start making the y's increase. So that's y to the 1st power. My third term then has to go back to positive. What we don't know is this coefficient, but we do know it's x to the 22nd power, y to the 2nd power. Remember, these coefficients have to add up to whatever this exponent is here. If it's a minus sign, the signs have to alternate, positive, negative, positive. The first coefficient's 1. The second coefficient is the exponent of whatever the expansion is, whatever that original binomial is to whatever power, whatever the exponent is. So now we just have to fill this in here. So it's the third term, so we have 24 terms. We're choosing, remember how to get k? So if we wanted the third term, then k is 1 less than that, so we're just choosing 2 instead of 3. So now you just have to use your calculator, do 24, choose 2. So I'm grabbing my calculator to do that as well. So I get 276, so it's x to the 24th power minus 24x to the 23rd y plus 276x to the 22nd power y squared. So here are the first 3 terms of this expansion, which is way easier than actually doing Pascal's triangle and finding out that the third term would be 276 as you add it down to 25 rows. Okay, finally, number 8. What is the 18th term? So this is related to k, so k is 1 less than that, which is 17. Of the 200th row. So remember, row 0 is when it was to the 0 power. Row 1 was when it was to the 1st power. Row 2 is the 2nd power. So the 200th row is going to be the 200th power. So the 18th term, if we just did x plus y, sorry, it doesn't say that. So if we did x plus y to the 200th power, it could just be asking for the coefficient of that, but let's just go with the 18th term of this right here. So we know we're going to have 200 choose 17, x to what power, y to what power. So remember, what is it? Look at the formula. It's n minus k. So it's 200 minus 17 here, which is 183. And then this has to be 17 here, because they always have to add to 200. So 200 choose 17 is a huge number. Yeah, I thought so. So it's 1.83 times 10 to the 24th power, x to the 183rd power, y to the 17th, I think is what I get. 18th term of the 200th row, so it's a little bit crazy, but that is the coefficient, and here are the two terms. Probably won't give you something quite that crazy, but it is just trying to reinforce those formulas and how to find a specific term given a specific expansion, given something to the whatever power, binomial taken to a certain power. Okay, so I will see you in class to practice some of these. Again, please ask me questions. Please make sure you're practicing because I know it gets a little complicated. See you soon.